We're looking at the Antarctic sea ice over the last 50 years and trying to understand why the sea ice extent has actually been increasing a little bit, whereas in the Arctic we've seen substantial decrease in sea ice extent. So trying to understand this has been somewhat of a paradox. Sea ice can melt both from above and below. In the Arctic, the melting is dominated by what's happening at the surface in terms of the heat fluxes from the atmosphere. In the Antarctic, it's actually dominated by the heat fluxes from the ocean. There's a lot of warmth at depth that then melts the bottom of the sea ice. As warming increases and we get more and more rainfall and less snowfall, that at some point there's a transition to less sea ice in the Antarctic. Well, in this study we used two global climate models, the one from NCAR and from GFDL, both US models, and we used these two models because they did the best job of all the models of simulating the Southern Ocean and the Antarctic climate. And we used the simulations to sort out the influences of natural variability versus the anthropogenic forced variability. In terms of what the findings mean for the future, it's possible that we will see sometime in coming decades a transition, whereas overall we're going to see a decrease in the Antarctic sea ice.